Okay. Let's see. Are you guys all seeing the Jamboards? Yeah. Okay. Um, observations. First of all, observations about what did you guys notice? Like, what did you guys all find the same thing? Did you guys not find the same thing? Did people find different deflections, different amounts, different? What was the observation? Yeah, Dan.
It seems like we all found that the wire deflected clockwise.
Okay, is that true? Isabel and then Hayden.
I know in our group we didn't, specifically between the first and second, or the one with two batteries and one battery, we all sort of got different, not all different directions, but like half of us got clockwise and half of us got counterclockwise.
Okay.
Yeah.
Yeah, Kian.
Yeah, and to Isabel's point, we were just, since we got those results, we were kind of curious to like just see what everyone else got, because we were wondering if we were doing it wrong, to be honest.
Mm-hmm.
For our group,
Yeah.
We got counter or clockwise, and then when we switched wires, we got counterclockwise, which I think is how it was showed.
So, what I'd like you to think about, and so theoretically, like looking at the drawing from group 1 on wire 1, right? This side here, again, if I annotate, let's see, where can I annotate? There's my, okay, so if I annotate, this is the negative end of your battery. This is the positive end of your battery. So this is a negative end, the negative end, the negative end, right? And this is the positive end right here. Because if you follow all the way across, you get positive ends, etc. over here. So you see that the charges are the electrons, which we represent with an E minus. They're leaving through the negative end, right? And you see how they're entering through the south end of your compass, right? They're going this way, with the south end of the compass being here and the north end of the compass being there. Do you guys see that? That should create a clockwise deflection. Okay, that should create a clockwise deflection. My bet is that if you simply were to take this compass and move it over here, like this, right, with a red here and the white there, what you'll see is that the charges now, the electrons, are still moving this way, right? But now they're entering through the north and they're exiting through the south. And that's going to give you a counterclockwise deflection. So you have to be very careful when you measure the deflection in two different wires. You need to be super careful that you're always using the same orientation of your circuit. Meaning, you should always try to have the negative end, right? Whatever, like, so in this, for this one, this is a negative end, this is a positive end. For this compass, this is a negative end, and that's still the positive end. But now your negative end is on the north and your positive end is on the south. And if you do that, then you're going to get a counterclockwise deflection.
Right? Yeah, I think that's what we did, where we kind of just we left the circuit where it was and we moved the compass and slid it over, and then
that is a super classic mistake. So it's not a big deal. Like, it's the first time we're ever doing this, right? But that is like the number one mistake that people make. The other thing that I want you to see is that, at least in this picture, there's the picture of the battery, the compass, the light bulb, everything. So I can figure out the orientation of your circuit. If I look at this picture, on the other hand, it's hard, right? One, I don't know whether, it's hard for me to tell whether it's just like this wire is just sitting on the compass and the deflection was counterclockwise, or whether there was never a deflection in the first place, right? And I have no idea where this, like, what end is this one and what end is that one, right? So like when you're going to be doing your challenge for Monday, make sure that your picture includes the, like, how your wire is connected to the battery, because that's the only thing that can actually demonstrate whether this makes sense or not. Like, okay, so again, here, right, you can see like this is the positive end, this is the negative end, and so you see that now here I can see that this is coming out of the positive end, so the positive end is here, the negative end, oops, what's going on? Why? The negative end is there, right? And so if the charges are going into the north and out to the south, that should be a counterclockwise deflection, ideally, right? So those were your observations for, let's see, I need to erase what I just did. There's my tape eraser so that I don't have all this stuff on there. Okay, over here. Oops. Stop the annotating. Thank you. Okay, and then, so what's interesting is you're saying that when you switch to from, and again, I think it's the problem is like when you switch from two to battery to one battery, I'm not sure you kept the orientation constant, and so it's possible that you made a mistake that way. It sounds like everybody though agreed on the fact that the more batteries, the greater the deflection. I think I can show that. Basically, so let's see, maybe if I stop sharing this one and I see if I learned something today. Spotlight that one, right? So this is my circuit again. I don't know if you guys figured out, but like when you look at the compass, they're like little individual tick marks. Each tick mark is about 5 degrees. So when you have a deflection of one tick mark, it's about 5 degrees. And let me see if I can, let's see. Right, so I'm just gonna do oops, like that, there we are. Okay, so again, this is the negative end of my battery, negative of my wire, positive end of my wire. If I go the negative over the south, I get a clockwise deflection. And if you, let's see, if I take it out, I'm gonna put, so I can actually read it, come on, there we are. So I'm aligning the north with the north with the north. And then I'm putting on here and I get about 1, 2, 3, deflections for 2 batteries. So that's about 15 degrees. And if I now move it to just 1 battery, first of all, my light bulb is way less bright. And if I still have a clockwise deflection, but now it's only about a unit and a half. So it's about 7 degrees deflection. So what I get is it sounds like I get about 7 degrees deflection per battery, right? Let's see, I'm going to turn the spotlight. View all, gallery. Again, this is going to be super important because in some cases, you will be able to find a deflection even though your light bulb doesn't light. Some light bulbs require a minimum amount of current before they glow, right? It's because otherwise the electrons are moving too slow. But there will be a current. It's just you won't be able to see it as a light bulb glow. But if you put a compass underneath it, you will be able to see a deflection. So the compass in that way is a much better measurement for the amount of flow going through those, right? And what you can see is that because you can get clockwise and counterclockwise deflection, we can actually detect which direction the current's going in, which is kind of cool. Any questions so far? Yeah, Hillary.
Is there a way to detect or is there a way to like make a compass deflection without the light bulb?
Totally. Yeah, no, the light bulb is only there to be pretty so that you can actually see that something's happening in your circuit. Otherwise, all you would see is otherwise. Actually, that's totally fascinating. Why don't you guys do the experiment? Tell me what you find.
Wait,
if we
Nicola.
So do the circuit, remove the light bulb, right? So basically you're just getting like 2 batteries and like maybe 2 wires attached to one another, right? No light bulb. And the question is, do you get more deflection or less deflection?
Does that like do anything to the batteries? Won't it like short them or something?
It's called a short circuit. It's not great for the battery, but our batteries will survive. My question is, do you get a bigger deflection or a smaller deflection?
Much bigger deflection.
Much bigger deflection. Elliot, you look confused.
Yeah, I didn't get any deflection.
Well, your wires have to be connected to the battery and they have to be connected to each other.
Yeah, they are. I just did.
Without the light bulb.
What?
Right?
No light bulb.
Oh yeah, but no. So what you have to do is okay. So look at my right. What you're gonna do is you're gonna disconnect the light bulb holder, get rid of the light bulb holder altogether, and then all you're gonna do is you're just gonna connect one to the other like that, right?
Oh, okay. I connected it to like the.
If you do the light bulb holder without the light bulb, there's no connection, and so you can't have a circuit. And in fact, I get whoa. Like it's starting to move. Like it's centimeters away, and it's already starting to move.
Is it supposed to like smell smoky after a little bit?
Yeah. So I'm getting like 60 degrees deflection, right, for 2 batteries. So instead of 17 degrees, I'm getting 6. So what does that tell you? If we understand that the amount of deflection is the amount of current, what happened when we put the light bulb in?
It's taking up some of that electricity.
Right? So it's like a river going slower. Yeah, Isabel.
Oh, I was just gonna say, for me at least, your audio seems to be going like in and out a little bit. Like I can still hear you, it just goes softer and louder.
Oh, that's because I had to take away the audio adjustment. I can put it back on if you want. There's a automatic adjustment for microphone level. When I tried that with the hybrid technology, it like completely saturated my computer. So, but it's okay. I'll put it back on. We'll see what happens when we go hybrid. Yeah, Elliot and then Ramsey. Elliot, you're muted.
Oh, sorry. My like battery cables are smoking now.
Yeah. Please disconnect them. Right. You should not. Right. You should not. You're shorting the battery. This is not a good thing. Like this is dangerous. Ramsey.
So if the negative going towards the south side is a clockwise deflection, what was the counterclockwise deflection again?
I'm gonna let you think about that one. Because that's the only thing you have left to think about for Monday. So okay, it is 9:52. This time I'm not gonna make the same mistake. We have class till 10:15. Why don't you guys take a little break, right? We'll meet back up at 10, and you guys will start working on your deliverable for Monday.